Now that we've spent some time looking at quadratic equations and we've looked at using the quadratic formula to solve a quadratic equation, we're going to apply that quadratic equation to some non-quadratics. And the reason we're going to be able to do that is because if we look at the quadratic and the linear term and we look at how they're related, notice that the quadratic term is going to be the square of our linear term. And when we solve using the quadratic formula, that variable that's part of our linear term, that x, is what we're solving for. It's x equals negative b plus or minus the square root of b squared minus 4ac. So I'm going to take that and I'm going to apply it to this degree 4 problem. So we talked before how we could use factoring with degree 4, and I look at this and I know I could factor this to get my answer, but I want to actually take the longer method, and I'm going to take the quadratic formula to solve it so I can show you how that works. So if I'm trying to solve this, the first thing I'm going to do is I'm going to plug 0 in for f of x. And now because I look here in my middle term, in my first term, notice that this is the square of this variable here. Just like in a quadratic equation, this quadratic term is the square of this term here. So it still has that same relationship, which is why I'm going to be able to use the quadratic formula. So I'm going to go ahead and say that my a is 1, my b is negative 5, and my c is 6. But now, instead of using the quadratic formula to solve for x, I'm going to solve for x squared, since that's what's going to be in place of my linear term. That's my middle term. So I'll have x squared equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a, which of course reduces to b x squared equals 5 plus or minus the square root of 1 all over 2. So I'm going to go ahead and say that x squared equals 5 plus the square root of 1 is going to be 6 over 2 will be 3, or x squared is going to equal 5 minus 1, 4 over 2, which is 2. So now from here I'm solving for x. So I'm not quite done. I have to take another step that I traditionally wouldn't take when using the quadratic formula. I'm going to go ahead and solve each of these for x, remembering my plus or minus, and I get x equals plus or minus the square root of 3, or x equals plus or minus the square root of 2. And since neither of those radicals can be simplified any further, I'm going to go ahead and leave that as my final answer. In this same video, I want to look at one more example. So it's again, using that quadratic formula, but now instead of having degree 4 in a square, we're going to have degree 1 in a radical. So if I first put this into standard form by going ahead and subtracting the 6, I get 2x plus square root of x minus 6 equals 0. So I look, and my middle term here and my first term here again are related by a square. X is the square root of x squared. So because they're related by a square, I'm going to go ahead and use the quadratic formula. But again, instead of solving for x or x squared as we did in the previous example, now we're actually going to solve for the square root of x. My a is going to be 2, and my b is going to be 1, and my c is going to be negative 6. And I'm going to get the square root of x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, which is going to be negative 1 plus or minus the square root of, and I'm sorry, this should have been a negative 6 in here, making that 1 minus a minus 48, so I get 49 all over 4. I know the square root of 49 is just 7, so I'm going to go ahead and simplify that, and I get the square root of x equals negative 1 plus or minus 7 over 4, which means the square root of x equals negative 1 plus 7 is 6, 6 over 4, or 3 over 2. or the square root of x, negative 1 minus 7 would be negative 8 over 4, or negative 2. Again, even though the quadratic formula allowed me for this to find the square root of x, I really want to know what x is. So I'm going to go ahead and I'm going to square both sides because when I wanted to get rid of the square in the previous example, I took the square root. Now when I want to get rid of the square root, I'm going to go ahead and square both sides, giving me x equals 9 over 4, or 4 for my two final answers. The big thing that we're going to always remember is that quadratic formula is generally going to be used to solve quadratic equations. However, if my two terms are related by one being the square of the other, I can apply this quadratic formula to other equations.